Hey guys, today we're going to be reviewing solving inequalities. Hopefully you remember a little bit about this from last year once you get done watching this video. Hopefully it'll dust off those files from last year. So when we're talking about inequalities, we're talking about these symbols that you see on slide 2. We're talking about less than, greater than, less than or equal to, or greater than or equal to. You probably learned in elementary school that the alligator mouth always eats the amount that is larger. So whatever our symbol, whatever the open part of our symbol is facing, that is what is bigger than the other part. So on slide 3, for our purposes, it is important that you always read inequalities starting with the variable. When we were younger in elementary school, it was pretty easy because you were probably comparing two different numbers. But now that we're in the world of algebra with inequalities, you know we're going to have variables. So the variable can be on the left side of my inequality, or the variable can be on the right side of the inequality. One of the tricks that I use so that I don't get confused is I always start with the variable. So if you read the variable first, it'll help you understand what the statement is being made. So for example, x is less than 7 is how I would read this first inequality, but I can also write x is less than 7 this way. That sometimes confuses kids because it looks like the symbol is going in a different direction. But if you read it starting with the x, you can see that the alligator is eating the 7 in both of these cases, so x is less than 7. The next example, x is greater than or equal to -3. That would be the same if I read the variable first on this problem. X is greater than or equal to -3. All right, so it's very important that you find the variable first and then you read the inequality. Sometimes we might even have to read right to left instead of left to right if they're flipped, okay? And then we're also going to talk about double inequalities in this lesson. So double inequality looks like the last example here. We have an x in the middle, and I always like to read these one at a time. So I would start by reading this part of the inequality. X is greater than -2, and x is also less than or equal to 11. So that is a double inequality. It means x can be greater than -2, but it can also be less than or equal to 11. When you are reading or working with inequalities, sometimes underlying keywords can help you translate those words into symbols. Does this, you want to ask yourself, does the phrase mean that it includes the given value, or does it mean that it does not include the given value? If the phrase includes the given value, then we're going to use those less than or equal to signs or greater than or equal to signs. If the value given is not included, then we're just going to use our normal less than sign or greater than sign. So here's two examples. For example, m is more than 14. Can m equal 14? In this case, no. M has to be more than 14. So our inequality would be m is greater than 14. 14 is not included in the solution. The next example, t is not less than -2. So t is not less than -2. That means it has to be bigger than -2. But can it equal -2? Yeah, because equaling -2 is still not less than -2. So for this example, I wrote t is greater than or equal to -2. So you always want to underline keywords. You want to ask yourself, is the value that I'm talking about included, so I need an equal, or is it not included and I just need the regular inequality symbols? When you have two phrases that are combined, the variable is going to go in the middle. And again, I take these one at a time. So b is greater than 0. I'm going to put b in the middle. I know b is greater than 0, so the alligator has to eat the b. All right, and then I know that b is also less than or equal to 25. I already have the b in the middle, so I just put my less than or equal to 25 there as well. X is not less than -2, so x is greater than or equal to -2, and X is more than 9, X is greater than 9. So you're going to put the variable in the middle, and then you're going to have to write this part of the inequality, kind of reading it from right to left. So keep that in mind to make sure that your symbol is going the correct way. The other part that's review is how to graph inequalities. So we're going to start by graphing inequalities on the number line. Remember, if you have an open circle, which means it is not shaded, that means that that number is not part of the solution. It is not included. If the circle is a closed circle or a shaded circle, that means that the number is included as part of the solution. For less than or equal to, we're going to shade to the left because that's where the numbers are that are less than. And for greater than or equal to, we're going to shade to the right because that's where the bigger numbers are. So here are some examples. If they tell you that X is equal to 3, you're just going to put a dot on 3. That is all X can be. X can only equal 3. That's where we put our dot. If they tell us that X is greater than or equal to 3, now 3 is still part of our solution. So we put a closed or shaded dot at 3, and we also can include anything that is greater than 3 as part of our solution set. So we're going to shade the number line to the right, and we're always going to put an arrow at the end because those solutions keep going forever and ever and ever all the way to positive infinity. For X is less than or equal to 3, again, 3 is included in our solution. So we're going to put a shaded or closed circle at 3. And this time we're going to shade everything to the left of 3 because we also can include any number that is less than 3 as part of our solution set. If they give us X is just greater than 3, now 3 is not part of our solution set. So we're going to put an open circle at 3 so that everyone knows it is not included in our solution set. And we're going to shade to the right because, again, we want greater than 3. Those are part of the solution set because they're shaded. If X is less than 3, again, we're going to put an open circle at 3. We're going to shade everything to the left because those are solutions because they are less than 3. All right, so today you're going to practice, you're going to use your shape and line tools. So if you come right up here, you can use your circle shapes, all right, to make either an open circle or a shaded circle. You can choose any color that you want. Then you're going to come down here to our lines and you can select the arrow. And then you're going to practice graphing some inequalities today. All right, so I did the first one for you. X is less than 5. X cannot equal 5. So 5 gets an open circle, and then I shaded to the left. To make this line bigger, all I did was I came up here to line weight, and I made it a little bit thicker. All right, you can do that over here with your arrows. You can pick the direction that your arrow goes, etc. So give that a try on slides 8 and 9. All right, for slide 10, I gave you the inequality graph. You are going to write the inequality statement that matches the graph. And I gave you these symbols right here so you can copy and paste them instead of going to insert special characters. I thought that might take a little bit less time for you to just copy and paste the symbols from here and put them in the text boxes. There are a couple double inequalities in there. So again, make sure your variable is in the middle. You can choose any variable you want. When they don't give me a variable, I usually just use X, but you do you. All right, and then the last thing we're going to review is solving inequalities. So if you have an algebraic inequality like this, 2x minus 4 is less than 8, you're going to solve the inequality just like you would solve a normal equation. So we're going to get rid of addition or subtraction first, then we're going to get rid of multiplication or division. So in this case, I would add 4 to both sides. That gives me 2x is less than 8 plus 4 is 12. To get rid of multiplying by 2, I'm going to divide by 2 on both sides. And then that leaves me with x is less than 6. And now I'm going to graph this inequality on the number line over here to the right, just like you did the inequalities earlier. Use your shape tools and get those on there. All right. You're going to work on those all the way through to the end, slide 13. If you have any questions or concerns, of course, make sure that you message me, and I will help you as best I can. And you can also do this on Kami. I believe you can open this in Kami, or you can save it as a PDF first and then use it in Kami. But I think that you should be okay with the line tools. All right, so give it a try. Message me as always if you have any questions or concerns, and we'll move on when I see you next time in person. Have a great day. Bye.